Black Basta Ransomware Layer Linux.
Hi everyone, thanks for watching laurieWIRED, and in this video we're going to be dynamically analyzing the Linux Black Basta ransomware family. So we're going to run two different samples and see what they're doing and if we can find different interesting behaviors that are categorized for this ransomware family. We're going to see if we can trigger the encryption behavior to find out what particular files that this ransomware is targeting for its encryption. We're also going to see if we can get the ransom note and maybe try to decrypt one of the encrypted files if we can. So let's get right into it. I'm going to open up my GitHub repository, and this is the malware analysis environment that I'm going to be using today. I'm going to be running this inside of a Linux Docker container that is going to be living inside of an Azure virtual machine that is running Ubuntu. And if you are not familiar with this, I have a previous video showing how to use this Linux container and set up your secure malware analysis environment without infecting yourself. Let's move on to the different samples that we're going to be looking at. I have two Black Basta samples that I will make available for you in the comments section of this video. They're found inside of Malware Bazaar. So this is going to be the SHA-256 hash of the first sample. And then we have a secondary one that is targeted for Linux that is also tagged Black Basta. So I kind of want to figure out what's the difference between these two files, what are they doing, and is there any dynamic behavior that I can actually see to help me figure out what this is doing and how it is significant. So I'm going to go over to my virtual machine, and I have these two samples here already. So let me just show you. We'll just look at the SHA-256 for both of these, and these should match the ones that I shared in Malware Bazaar. So I'm going to run my Docker container, and that's going to copy both of these files to that container so I can dynamically run them without actually infecting my host virtual machine. So I'm going to do run my shell script and pass both of these files as arguments to this script so that they get copied over to the Docker container. So I'm going to do Black Basta 1, and then Black Basta 2. And then this is going to copy both of those over to my container and start up a secure analysis environment for me to analyze in. So if I do ls, you can see I have both of my samples here. I'm now connected via an interactive shell to my Docker container that is also based off of Linux. So here, I think I'm just gonna first of all probably try and run the samples and just see what happens, because I don't really care about infecting this environment. It's totally fine if I do. I just kind of want to know what happens if I just run it. So I'm gonna do /, and let's just try the first one. Okay, this looks like it is probably the decryptor for the ransomware. So if you're not familiar, ransomware usually has an encryptor file that's going through and actually infecting the host and targeting different files on the host for encryption. So when it's done with its encryption, then it lets the host know that they need to go to a particular domain or contact someone to get their files decrypted. But what you might not be aware of is that the ransomware authors actually need to have additional software that will go through and decrypt all of the different files on the device, so that the victim, if they pay the ransom, they can actually get their files back, or else nobody would really pay the ransom. So I think this first sample here is actually the decryptor part of this Black Basta Linux ransomware. So this is probably going to look for a particular path to decrypt that's maybe passed to it or something like that. So I think I'm going to try the secondary file, and I'm actually just going to see what's happening with that, since I would rather trigger the encryption first before looking at the decryption process. So I'm going to do // Black Basta 2. And this definitely looks like our encryptor. It's saying encryption instead of decryption, which is definitely a start. But we're not actually triggering any behavior. Let me see if I can write a file in this directory or pass a directory to it to maybe trigger some encryption behavior. So I'm going to do echo hello world. Then maybe write a file in this particular directory. And we'll just call this hello.txt. So now I've got a temporary file here that's saying hello world. So let me try my second BlackBasta sample, which is my encryptor, and see if that will encrypt my hello.txt file and maybe create a README and a ransomware note. So let me do /BlackBasta2. And we're still getting the same error code, so it doesn't look like that's working. And if I do my cat hello.txt, I still see this file is not encrypted. So next thing I want to try is I want to see if I can pass a directory to it and perhaps trigger the ransomware to actually encrypt that way. Some of these require command line arguments, so that's always a promising option to try. So I'm going to do /BlackBasta2. And let me do the current directory. So let's just do /home/app. And it doesn't look like anything is actually happening. Yep, we still have our plain text hello world on this. So I think this is not the way to go. So I think what I'm going to do from here is I'm going to use strace to actually see the different system calls that this ransomware sample is using. And I'm going to see if I can figure out why this is getting triggered. So let me do strace. Let's do BlackBasta2. And let's do -f in case it makes any forks, so that we follow the child processes just in case this forks itself. Maybe /. There we go. That did it. So it looks like we have this write is what we were interested in. That's where it's writing to the console. 1 means standard out, and it's saying path not exists in this system. But if we look at the line above this lstat command looks like it's getting some information about this /VMFS/volumes directory. So I'm wondering if this is the reason that we're getting this error message instead of actually seeing some encryption inside of our ransomware. So I think what I want to do now, let me see if I can find anything interesting in here. No, it's actually really short. It's basically just loading a ton of different libraries that it might need, mapping them into memory, changing them to protections so that it can execute, generating a random number, and then it pretty much goes straight into its encryption process where it's trying to open this VMFS/volumes. But this itself is very interesting to me because this /VMFS/volumes directory is actually associated with VMware ESXi servers. These generally contain different VMDK files, which are actual files related to virtual machines. So this actually looks like it's targeting hosts that might be storing virtual machines themselves. So probably your different servers that are hosting your VMs. And it's probably trying to encrypt all of your different hard disks that are associated with your VMs. So I might have to create some example VMDK files to see if it's going to encrypt those. Although right now we're getting stuck on this particular directory check. Since if I go on my container, and if I do ls, let's do ls/. Let's do ls-altr/ so we can list it. But if you look here, I actually do not have a folder called VMFS, which makes sense because I don't have any virtual machines stored inside of this Docker container. So the next simple thing I want to try to trigger some behavior is just to create this directory with some example files inside to see if they actually get encrypted. If they do not, then I'm going to try putting some example VMDK files inside of there to see if it's maybe checking the file extension. So let's just go ahead and do that. I'm going to do cd/, let's just make dir VMFS, and then that looks good. Do make dir VMFS/volumes. So now that directory should actually exist. And I'm going to go back to my home apps directory. And let me just maybe move my hello.txt file that I created right here in the hopes that it would get encrypted. I'm going to move that file over to my VMFS/volumes directory to see if maybe now it will get encrypted if this appears to be in the directory that this ransomware is targeting. So I'm going to do mv hello.txt, and let's move this to /VMFS/volumes. So we'll do cat /VMFS/volumes. Oops, gotta add my file name. Looks good. We've got our hello world file right here, all not encrypted. So let me try running my encryptor again and see if that actually encrypts this particular file. So I'm gonna do /BlackBasta2 since that was our encryptor name. And we did indeed get some different behavior. It looks like it took time to actually encrypt our file. So now I kind of want to go and check this hello.txt file and see if it did successfully get encrypted this time. So I'm just going to do cat one more time. And it looks like that file actually doesn't exist. So let me see what's in that directory now. Maybe it actually changed the file extension to something different. So I'm going to do ls/VMFS/volumes. And it looks like we have two different files in here. We have a readme, and we have this hello.txt.basta. So that looks different to me, and it's also executable for some reason. I don't know why. Let me see what's in these two different files here that seem to have been created from our ransomware. So I'm going to do cat /VMFS/volumes, our hello.txt.basta. And that definitely looks like some encrypted bytes to me. It just looks like junk code. So that's interesting. So it looks like we were successful in triggering our encryption behavior. And it seems like our ransomware is actually kind of simple in this way, that it's not checking the extension of the file. It seems to just be encrypting absolutely anything that happens to be in this VMFS volumes directory, which actually makes sense since it probably doesn't care. It just wants to encrypt everything on that system in that directory. But now let me look at our readme.txt /readme. And it looks like we have successfully gotten the actual ransom note. So that's really interesting. Looks like it wants us to go to a Tor website, which is going to be .onion. It's giving the company ID for the particular company that it was targeting in this case. And it's saying and telling us our data is stolen and encrypted. So that's really interesting, and it looks like we have successfully found the ransom note as well as triggered the encryption behavior based off of the particular directory that we're looking at. Now what I think I want to do is I want to just double check and make sure that it's not trying to encrypt any other directories that we might be missing now that we know exactly what it's trying to target. So I'm going to do rm, let me just cd into here, rm-rf star, looks good. And I'm going to cd back into my directory, and I'm going to run this successful encryption with strace so I can make sure it's not targeting any other folders that I might be missing. So let me just actually make one more example file. That looks good. So that's our example file that's ready to get encrypted. And then let me go back to my ransomware directory. So let's actually try and run our encryptor and see what the output is inside of strace for the entire behavior. I'm actually going to rename this so I don't get confused and call it Decryptor Black Basta, because we know what this is. And the first one was the decryptor. We already saw that it was trying to decrypt. So let me do this, and we'll call this Decryptor. All right, that looks good. So now let me do strace-f to follow any child processes. And we'll do -o to output the strace log to a text file. I'm going to call this strace out.txt. And then we actually need to run our file, which is going to be the encryptor. And it gives us our successful encryption message, tells us how long it took to do the encryption process, very quickly since we only have one file inside of here. And let me look at our strace out. And not too interesting, it's just loading its libraries right now. Mapping them, so let's move on until we get to some interesting behavior. This looks like the beginning of our ransomware, so we see our encryption message right here. And I'm going to keep on moving down. It's finding our VMFS volumes directory. It's also getting the current working directory. And it's also getting the CPU number. So I think that what it's doing now, if I go down, it looks like it's actually creating a ton of different threads. So oftentimes ransomware will have multi-threading so that it can encrypt the system really fast. So I think it's seeing how many CPU cores we actually have available for this device so that it can schedule all of the different threads and make this ransomware encrypt very fast and efficiently. I'm just gonna go up to my interesting part one more time. I'm not actually seeing any other directories that it's checking for, so I think this is really simple ransomware and it's only checking for the VMFS volumes directory. Let me just go down. I think that looks good. Just a ton of threads. Let's go to the bottom and get all the way through this. Here we go. Here, it's getting the hello.txt file and it's opening that. For some reason, it's making it executable with chmod. I don't know why. And it looks like it's exiting some threads, reading in the text that is part of that file that I created, renaming from hello.txt to the new hello.txt.basta to let it know that it's already encrypted this file. And I think that's pretty much it. Then it's just writing to the console that it has successfully encrypted all of the different files. So I don't think we're missing any directories here. I think we've pretty much caused the full behavior of this ransomware. And if we wanted to make sure, we could dive into the code into Ghidra just to make sure. But I'm not too worried about it for this case, since we know at this time that this is definitely ransomware. So now I'm going to exit out of this. And let me try running my decryptor and see if I can actually trigger it to decrypt that hello.txt file that it gave us, now that we actually saw the encryption and saw the ransom note. So let's just try running that and see. And if you remember, it was giving us that same error about the directory, so I'm guessing that it was also looking for that VMFS volumes directory. And if we wanted to, we could run strace again to actually find what directory it's looking for. But I'm gonna guess it's looking for that, and I'm gonna guess that this time it's gonna be successful. So let's just go ahead and run it and see. So I'm gonna run this with strace again because I wanna save my output just in case. I'm gonna do -f, -o, I'm gonna do decryptor out.txt, and then our actual decryptor ransomware. And we did indeed successfully trigger the actual decryption, so it was looking for that VMFS volumes directory. And it looks like it gave us again the time it took to decrypt. So let me see if we got our actual bytes back from that. Let me go ls/vmfs volumes, and it looks like it did successfully rename our text file, although we still have our ransom note right here. So let me just see cat vmfs volumes hello.txt, and it looks like it actually did not fully decrypt this file, but it did change the bytes of it. So it really gave us more encrypted looking bytes, but it's a lot shorter than it was. I'm wondering if this is some kind of key or something like that. So I'm going to try and just play around with this a couple different times and see if I can get it to actually encrypt or decrypt the bytes again. First, I just want to see, what does the encryptor do if I actually try and encrypt these bytes again? So I'm going to do /, the encryptor. And let me just see what it did. So it renamed our text file again. Let me see what's inside of that. And then we have our hello.text.basta. This does look like encrypted bytes, but if I scroll all the way back up, these were actually different bytes. There was a K in the very beginning of this, and now that K is gone. So it did encrypt that key again. So I'm really curious what this does. Oops. What this does if I run the decryptor on this again. So it definitely wasn't the same bytes from the initial hello world, but that makes sense because we were passing it different data. So I'm going to try running my decryptor one more time and see what that gives us for these bytes. So I'm gonna do strace. We'll call this decryptor out2.text. And then I'm gonna do the decryptor. And it was Black Basta. And that should, I think that looks good. That should trigger our decryptor again. So first let me see what the strace looked like. So I'm gonna do vi. Take a look at that. And nothing too interesting. It's opening up its library files. Let me see if I can get to the interesting parts of this and just kind of scroll down. Looks like it's just doing multi-threading as well. Oh, and here we go. So it is opening up, getting our current working directory, opening up the VMFS volumes directory and finding our .basta file. And it looks like it is getting that information. Let me see, changing it to executable again. I don't know why. And let's see what it's writing to it. Reading in the bytes, I think. So this is probably the bytes from the encrypted file. And I do see our hello world string in here. These were the original bytes that we had added to the file, if you remember, that hello.text. So it looks like maybe the second time it did actually decrypt this successfully. And here I think we've gotten to the bottom. Here's our write and saying done, successful decryption. Let me see what that file is now set to. So I'm gonna do ls/vms volumes. And we just have our two files. So let's do cat on the hello.text. And it looks like it did actually successfully decrypt our file. So now we know that we can actually decrypt a file. The sequence of events I did to successfully decrypt this was run the encryptor, run the decryptor, run the encryptor again, and then run the decryptor again. And then we ended up with the actual original bytes. So now we actually know how to use the encryptor and the decryptor properly to fully trigger the behavior of this Linux Black Basta ransomware. So thanks so much for watching laurieWIRED, everyone. In this video, we looked at the Linux Black Basta ransomware family and we dynamically analyzed two different samples to see what their behavior was. We figured out that one was the actual encryptor software and one was the decryptor application. We found the ransom note as well as managed to fully trigger the encryption behavior from the first Black Basta ransomware file. We figured out that it was looking for the /VMFS/volumes directory, commonly associated with VMware ESXi servers, and we saw it actually would encrypt anything inside of that directory. So finally we were able to actually decrypt this by running encryptor, decryptor, encryptor, decryptor. So thanks so much for watching laurieWIRED, everyone, and I'll catch you in the next video. Ha 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 ha. Oh no.